Hello guys, today we'll start discussing about the architecture of Harmony. So before we go into the discussion mode, let's see a short video.
HarmonyOS is designed with a layered architecture, which from bottom to top consists of the kernel layer, system service layer, framework layer, and application layer. System functions are expanded by levels from system to subsystem and further to function and module. In multi-device deployment scenarios, unnecessary subsystems, functions, or modules can be excluded from the system as required. Kernel Subsystem. HarmonyOS uses a multi-kernel design so that appropriate OS kernels can be selected for devices with different resource limitations. This subsystem provides basic capabilities for upper layers. Driver Subsystem. Hardware Driver Foundation HDF lays the foundation for an open HarmonyOS hardware ecosystem. It allows unified access from peripheral devices and provides foundation for driver development and management. The system service layer provides a complete set of capabilities essential for HarmonyOS, including basic capabilities for all devices and capabilities dedicated to certain devices. This layer contains the basic system capability subsystem set, basic software service subsystem set, enhanced software service subsystem set, and hardware service subsystem set. The basic software service, enhanced software service, and hardware service subsystem sets can be tailored by subsystems, and each subsystem can be tailored by functions, depending on the deployment scenario for a particular device form. The framework layer provides what you need to develop HarmonyOS applications. Application framework and ability framework, specific to multiple languages, like Java, C, C++, and JS. Java and JS UI frameworks, as well as multi-language APIs for hardware and software services. The APIs designed for different HarmonyOS devices vary according to component-based tailoring. The application layer allows you to develop applications powered by feature abilities FAs or particle abilities PAs based on the service logic provided by the framework layer. FAs and PAs are the basic units of HarmonyOS applications to implement specific functionalities. An application can contain one or more FAs or PAs. Their difference lies in that an FA has a UI, but a PA does not. For example, in a video call application, the main UI FA provides a UI for user interaction. PA1 collects videos recorded by cameras. PA2 beautifies the collected videos, and PA3 provides Super Night Mode. FAs and PAs can be downloaded, loaded, and run as required. Applications developed based on FAs and PAs achieve smart cross-device distribution of third-party services, delighting users with consistent and efficient experience. Take the video call application as an example again. When you download the application on your smartphone, the FA, PA1, PA2, and PA3 will all be downloaded. When you download the application on a smart TV that does not support beautification or Super Night Mode, only the FA and PA1 will be downloaded. This is the architecture of HarmonyOS.
Okay, that was the overall gist of what we are going to discuss about the architecture. The same thing we will elaborate during further slides, and we will try to see what each and every component does, and we will primarily focus on development of application layer and what the framework subsystem does, but we should also have a knowledge of what the kernel layer and system service layer is capable of and what it will do. And also one of the most important component, that is our HDF, hardware driver foundation, and the IDE and the compiling toolchain which is necessary for our overall development of applications. So we will concentrate on all these things now. Let's see, you can see all these things, right? So this is in one shot. So we will break it to pieces. First, we will start from kernel layer. From there, we will start off. The kernel subsystem in Harmony is based on abstraction layer concept where we call it as CAL, kernel abstraction layer. So here we can, the most important thing about Harmony OS is, as we saw, the same OS is used across all the devices, right? From very small hardware to very high-end phones. So we use a similar OS concepts everywhere. So the reason how it can be achieved is, so if you see this entire operating system architecture, so based on the need of the device that we are configuring, for example, let us take a very maybe a smart TV. We will take a smart TV where we don't need a very high Linux kernel. Even a light OS is sufficient, which meets the KAL format, and the corresponding hardwares are integrated with the use of HDF or driver subsystem. And in this case, we need a distributed management system, multimedia, multi-input graphics, multimedia, common event management, but we might not need telephony. Telephony is basically used for calls, SIM-related inquiry. So we use telephony stack for that, for basically for signals and calls. So that is definitely not needed for smart TV. So in the enhanced subsystem, we only need a smart TV dedicated service stack. And in the hardware, we might not need a location, biometric, wearable subsystems. So what I'm trying to explain over here is, with the same architecture, based on the build level, we will pick a particular subsystem to create the OS for that particular device. So that's how the entire technical architecture has been derived. So we see, currently we can see kernel. So this is an abstraction layer that is available. All the kernel subsystems, that kernels that are available, it can be a normal Linux kernel that we are having in all our devices, light OS, or any new Linux kernel or a microkernel that can come into picture should meet the expectations of KAL. KAL is nothing but same set of interfaces, similar set of interfaces, that is giving capabilities for thread management, memory management, peripheral management, or some of the basic network management interfaces. So any kernel that supports these interfaces can be part of this kernel layer, and the hardware layer, which is based on our hardware driver foundation, it allows our access of multiple peripheral devices, which meets the driver configuration of this. So that's how we make a common abstraction layer. Multiple type of kernels can get adapted to this. So that's about the kernel layer. So we have a very in detail design and how the IPCs work and how the memory management scheduler, everything works. Based on the teams and the work that will be allocated, further trainings will be provided for members who will be part of development of those. Currently, our more focus will be on application development and the framework that it is supported. So next, we have system service layer. The system service layer, basically, we can see it is divided into 4 parts: the basic system capability, the basic software subsystem, enhanced software, and the hardware service subsystem. So in basic system capability, today morning we discussed elaboratively in terms of introduction of use cases. We saw how the distributed OS is important, and we also discussed more about our soft bus that is required for our connection that helps in communicating with multiple devices uh, seamlessly. The distributed task system we will also discuss tomorrow morning. So today we will see how the distributed task scheduler helps in arranging the tasks and data management. In multi-mode input, this module provides you different types of input that is available. You can think input as feedback in terms of touch keys that is available in terms of VR and other places. We see different type of signals that are given through which the input is given. Graphics by itself is a big architecture. We have a graphics engine, lightweight graphics engine uh, that allows you to show the view, the display that is there. The complete display pipeline has a complete E2E operations where we can see the pages, how the view, how the windows are rendered, how each of the elements that are drawn. You can consider a button, uh, text editor, text view, all these things, how it is done. There is a complete architecture. In terms of security, security plays a very important role in terms of our Harmony architecture. Many of the times, if you would have seen, majority of you would have seen, while installing any application in your device, it tells these are the minimum set of permissions this application needs to get installed. Maybe one of the simplest of things is maybe it needs internet to do some connection. It needs access of some of the contacts or some of the read-write permission for your storage system. But if you go a little bit before in Android, if you see, most of these permissions were given at the install time, and we never used to know when what kind of permission was used. So that arrays a lot of security issues in terms of hacking your content, personal information, and transferring to the servers. But when you see the latest advancement that is happening, we see a permission is given to access a certain resource of the device only when it is needed. For example, when you need a location information, somebody is accessing your location, for example, your maps. So it tries to tell you, okay, turn on or give me the permission for location so that I know where I am. The same location is also needed for weather updates, some of this information. Uh, you can also think of enabling Wi-Fi or Bluetooth. In many cases, this location comes into picture. At the same time, we give some other special access for reading and writing contacts by some other, maybe your Truecaller tries to check the access. Can I access your contacts? Maybe you have some other messaging application that asks you, can I access your messaging stack, messaging storage system. So that is all about security. Apart from that, in Harmony, we have additional security for maintaining the distributed system that we will cover today. Coming back to the basic software subsystem set, we have common event management and notification. Common event management is something where we use events to communicate between multiple modules. This we will also do some hands-on to see how that works and how notification system works and how we should use it. Telephony, as I said, it's more to do with the calls, the network subsystem. So we practically get the access from the radio, the modem, and try to have a framework interfaces attached to both this, and this is exposed to the application layer. And multimedia, as we know, majority of social communications or anything that we do in terms of video, audio, majority of the images that we share, multimedia stack is very important. So you have audio player, video player, many of these things are part of the multimedia stack. In terms of DFX, it's more to do with design, how we design for excellence and how we can make this design components use for multi-device inputs and multi-device screens. So DFX module is used for that. Then we have MDSP. It is basically a mobile sensing development platform defined for Harmony. So here because we are virtualizing all our resources, we also need to have a streamlined stack to get different type of inputs from different resources and adapt them based on that. And device virtualization is the concept that is used uh, to make the device part of the device form. Morning also we were discussing about how we use the best of capabilities of the resources that are available, and that is nothing but a virtualization of those resources available for us in the pool. When you come for enhanced software service subsystem, here this is based on the device that you're working. This subsystem is activated. At the same time, all this might not be activated. As we explained with an example, the smart TV dedicated stack is used only when smart device build is compiled or it is formed. The variable, when we say a smartwatch or a smart band, that comes into picture. In IoT based devices, where we discussed about last week, our home solutions, majority of the subsystem of IoT device stack comes into picture. The next and most important one for us is the hardware service subsystem. We can have any type of hardware, and this can always keep extending. So we have a location using our, which is very important for us based on the chipset that is available. We have biometric recognition. When I talk about biometric recognition, we have 2 or 3 types of biometric, like the fingerprint sensor. We can also talk about our face recognition is one, another biometric recognition. In terms of variable dedicated hardware, these days we have a lot of sensors attached to our wearables. The latest one added is, apart from the gyroscope, accelerometer, and other sensors, right now we have SpO2 sensors and many other health related sensors that are getting added in IoT based wearable hardware. In IoT dedicated hardware, there are you can name it and we can have it, like smoke detecting sensors, where temperature sensors. So we can have n number of sensors. So this system service layer, basically written in C, C++, provides the services for the framework and application layer to access all these services. So that is the most important layer on which the majority of the applications or the other services from framework are depending on. So it provides all the information for the corresponding subsystems that were discussed, and this allows us to mix and match based on the device form. All these subsystems are handled, right? So the next important one and the most interested one for our topics are the framework and application layer. Here, the framework layer, basically, we have multi-language support. We have Java, C, C++, and JS components in framework, but we have a Java and JS UI framework, which helps us develop applications in both Java and JavaScript. So that is one of the key features of HarmonyOS, where we can develop applications in 2 different UI frameworks and still achieve similar functionalities. So the framework layer provides components where it allows us to manage the application start, stop, and maintain the life cycle of application. So in terms of application, we would have seen in the presentation 2 important components were discussed. That is feature ability and particle ability. Feature ability is a module which or an application which has a UI component attached to it. And particle ability is something where UI is not available. So in just hold on a second. Okay, sorry about that. I got wrong. This is a simple framework and application framework that we are seeing how these are linked to each other and how it is done. We will further explore about the framework layer in the coming slides. I would like to hold on a little and try to see if anybody have any doubts on the slides that we have discussed till now.
Hello.
Yeah.
Yeah. So in the previous slide, there was this component, right? Enhanced software service subsystem set. So could you
Yes.
just give an example, like how, what kind of examples for the dedicated services? Let's say for a smart TV, like what all dedicated services
Okay.
would be there?
Okay. Let us think of variable for an example. So in variable, what we have is something in variable devices. Most of our software stack is based on the sensors, right? Corresponding to the next module that we are saying, where hardware service subsystem is there. There needs to be certain enhanced services that also needs to be done, like a pedometer, which doesn't calculate the steps by itself. We need to feed some information, and the dedicated variable dedicated service will allow you to create that instance and directly give the information to the application layer. Whereas in terms of smart TV service, we can see in term special software things, software modules will be there for enhancing your video output. It also needs to do additional operations like checking the corresponding radios, whether you need to have a stack for your screencast, which is not needed for other modules, right? So these specific type of software services will be available in this enhanced software services.
Okay, thank you.
Yeah. Anyone else? If no more queries, we will discuss further. Okay, if not, I will continue. So let us see our framework in much more detail. So I think that is one most important thing that we are seeing here. So here also I have split the same thing in different form. So the same framework is split for the need of application, how for application to work, how it will work. So in tomorrow's session, we will again discuss in detail how this application different. We saw in the video also how the ability slices, FAs, PAs are all working. So ability is nothing but a single view of the device that has capability of performing a task. The ability can have a UI and need not have a UI. So this is more about the application. We will go in detail of it. So, but before that, let us see from again bottom up, what are the things that how application works. For any application to start off, when the OS starts, we have a basic process that is a foundation process. Once the foundation process is up, it tries to start the corresponding services that are linked for making our entire application system work. That is our ability manager service. This is used for making our abilities start, stop, and managing the ability, scheduling the ability. So it is used for that. And bundle management service is basically how our packages are installed. It helps in application installation, uninstallation. So we use that for that. And then we have permission manager service. Just now we discussed, right, how the permissions are given, whether it is for a location or a contact access, whether it should be a system service, whether it is a runtime service, whether it is a service related to security. So all that information service, this is a main service that handles it. And the distributor manager service, that is needed for a distributed access of devices across all the platform. So this distributed manager service is used. AppSpawn is the one which creates the process of application, preloads the resources for JS engine, and it makes sure most of our framework layer resources are initialized before the application gets started. So before the application started, what all services and the framework instances needs to be created, AppSpawn will take care of it. Then we have a graphics process or a graphics layer internally, which is majorly focused on creating a window manager service where each of our views are drawn, or we simply call it as a canvas, what all the things are drawn within the canvas. So everything is handled by the window manager. Window manager also makes sure which window can be having highest priority. Can we draw one window on top of other? Do we have the permission to do that? And the input manager service, where your keyboard is attached, or you can attach different types of inputs to it. Even the keys, volume up key, that is also an input. And you can connect to a Bluetooth device and add the input. So that also finally translates to input manager and gives a similar kind of an input to the application framework. Once we go a little bit up, we have a framework layer. So where we can see there are kits this is also module based on the module or the device form. These kits get enabled. Bundle, ability, distributed kit, UI kit, and security kit. So these kits, like the services are there. Bundle kit gives applications the interfaces for querying about the bundle, ability to access ability information, distributed kit to start, stop, access the distributed access and distributed data. The UI kit is basically for enhancing our UI capabilities and to provide specific features in UI. Security kit is basically linked to distributed kit that we will discuss in few slides. And then if you see, we have JS and Java SDK layer and the adaptation layer for making our JS application framework similar to our Java SDK. And finally, we have the application layer. Whatever I have put it in the white box, the application app. So that is a common example for any application or a app module in Harmony. So it can have multiple abilities. It has some common code for accessing data, and it has the resources to showcase in the application. So this is usually the simplest way of showcasing our framework. And again, if you need to do a little bit more analysis, we have more architecture on bundle, ability, distributed kits that we will discuss or provide more training on time-to-time basis. This is more of an intro of our framework and basic modules that are involved in our framework. So we will present this first, later we will enhance it. So anybody has any concerns or doubts or something needs to be discussed over here, we can discuss.
Hello?
Yeah.
Yeah, so in Android, a bundle is used for communicating between activities. So is it the same bundle that you're talking about?
No.
Is it
this is maybe in terms of Android analogy, bundle here is more to do with package. Package manager, you would have heard of package manager.
Yes. Okay.
This is that bundle. We are not talking about the intent and the bundle. That not that bundle. So if you guys are more familiar with Android terminologies, maybe I can give a little bit analogy in terms of that. Here, bundle is linked to packages, and ability is more similar to activity that we see here. And distributed kit is unique to Harmony. JS SDK is unique to Harmony. So majority of others, we have close connection on the similar lines of Android. Any other doubts or concerns at this layer? I think this is something that we have to understand. If not on the functionality of how each of these kits or services works, at least to know if I have to run an application, what are the layers it goes through, and maybe when you see some logs, you will get a brief idea, maybe which layer is throwing what kind of an error. So in that per se, this will help you to understand better. So then we will go, this is more in terms of Harmony's framework, architecture, and the application framework. Now we will see few unique capabilities of HarmonyOS. So one of the most important feature that we were discussing many times was intelligent softness. So the below architecture here is intelligent softbus architecture. Then we have a distributed architecture and one-time deployment for multi-device deployment. So as we say, as we know, tomorrow we have a dedicated session for distributed architecture where we will see more on that one. That is tomorrow morning. So now let us concentrate on what is softbus. So we all have discussed in multiple times, there is 1 plus A plus N, that softbus does something good. So we will try to see how it helps in doing it and how internally it has been done. So this also, let's see a little bit brief introduction on the lower to higher side. So on the down, we can see all the different types of radio connections that are available here. We can see WLAN, Bluetooth. BLE is Bluetooth low energy, where we use majority. I think few days back, somebody asked about beacons, Bluetooth beacons. That also runs on BLE protocol. So we have our smart bands, that also is BLE. Anything that is very negligible amount of energy, that means negligible amount of energy is needed, and it needs a basic communication through Bluetooth, it uses BLE. NFC, we know how the communication happens at a very small distance. Infrared is an inline communication. We have a USB, Ethernet, and modem, which is our radio signals. Right? So we have so many different types of radio signals. Then we have hardware software synergy, where no matter what kind of hardware we are having, we are trying to have similar kind of interaction that is available for our devices. That's the whole difference here. So the adaptation layers of each of this converting to a protocol stack that is proprietary to Huawei is established over here. So then we have a bus center, where we based on the type of communication that we have, we dictate the network topology that is used. It also helps in discovery and connection. Based on type of device and type of data that needs to be transferred, the decision making center and data computing center does this one. I will take an example to explain how it does. And on top, we have multiple devices. let's say we have, and we also use something called as one hop, right? From yesterday, we would have, or from last week, we have seen a lot of one hop. So one hop is basically, as I said many times, it's one tap on a device to do the pairing, connection, and data exchange between two smart devices which are under 1+8+N architecture, or internally it uses softbus. So let us take two devices, device A and device B. So the moment it gets tapped between them, one becomes the receiver, one becomes a server, and one becomes the client. And based on that, the initial communication happens through NFC. So it tries to give the information to the bus center, telling what exactly, what kind of connection needs to be done. The moment NFC is stacked, we also get the information of the, if B is the one who's the client and this is a server, the client would have shared the information of the Bluetooth in terms of BT MAC address to the connection, and the device starts communicating on Bluetooth immediately. So instead of doing the first time, it tries to do the discovery to see whether there is a device with the same MAC address is available. So once it does, the decision making center and the data computing center decides how the data should exchange between these two. The first exchange is always in byte format. It tries to give the information in byte. We have a special type of headers to understand what kind of information is exchanged between the two devices. That is also patented to see how this information is exchanged. So that is the reason I cannot share it. But we have a let us say it has a special header that understands what is the meaning of it. So the moment that kind of an header is received by device A, it starts doing a connection in Bluetooth device. Once the connection establishes, the Bluetooth device exchanges the Wi-Fi information also. Once the security information is exchanged, and then a Wi-Fi direct link is established. So the moment the Wi-Fi direct link is established, rest of the thing, we call it as a stream based, all the things gets communicated. Now at this point, there is no application that is doing any special job. Till now, both the devices were doing a connection between each them, and there is a dedicated link or a dedicated channel established between these two devices. And if you say in a much simpler way, you can think of a socket connection is established at the very low layer. So in a socket connection, what happens? There is a port that is listening, and there is another client that is writing the data into the server port. So that's what happens in the very low layer, where we have two sockets that are established a channel for communication. So then our application layer can decide what kind of operation that you want to do. If you are transferring when you are doing now, the applications can be enormous, but it depends on what two devices we are dealing here. Let's say we are dealing with device A as a smartphone, and device B is the water purifier. So in water purifier, definitely you will not get any information like screencast or any of them. Majority of the information that you get is based on the request from device A's application, that I need the information about the water purifier, when it was installed, when you have to be serviced, what is the quality of the filters. So this basic information is shared to device A. So based on the information, the device A provides a beautiful picture to the user about all the information of the device over here. So this is one communication. Let's suppose you have a tablet over here that is paired here. So we need to transfer few files. So then we go through the file operation. Why this dedicated system is used is based on different types of data that is exchanged between the devices. different types of channels can be used. There can be n number of channels established between device A to device B based on the type of data that is getting exchanged. The device profile also helps us understand what kind of device it is, what kind of data operation that it happens. The security module here makes sure none of the sensitive device is shared from a highly secure device to a low secure device. For example, we have some passwords. A very simple thing is your device password, screen lock password is there in device A. At any cost, it cannot be shared to a lower secure device compared to device A, that is tablet or a water purifier, using the security module. So this is a simple way of seeing our soft bus architecture. So with use case and this, I hope I have tried to explain how does it work. Maybe some of you can ask more questions where there was a little bit of confusion while understanding or the way I have put forward. So we can discuss further.
Hello.
Yes.
Sir, what exactly is protocol stack?
Protocol stack is something like how you need to communicate between devices. So when you talk about protocol stack, it can be a Wi-Fi communication that happens. It can be IP communication. It can be Bluetooth communication. So each of the hardware, when you have to communicate at the software level, it needs to maintain certain protocols. For example, what I was trying to explain, the header, body, how it has to be transferred, how the exchange of data. You would have heard about the HTTP stack, right? How it goes.
Yeah.
We have a header, we have different types of scripts that it supports, what kind of language you're transporting, what kind of encoding you're following. So the security protocols, if you go on HTTP to HTTPS, we also try to talk about whether it is SSL or TLS, what is the version, what kind of packages or intermediate tokens are exchanged to make sure both the device are authenticated. So majority of this is validated at the protocol stack.
Thank you.
So in terms of one-time development for multi-device deployment, it is more to do like our feature, right? Whenever we develop an application in Harmony, the same application can be utilized in multiple platforms. For example, we discussed this also. This is using our FAs and PAs. If you have a music player, the music service can be a PA which doesn't have a UI. So that is the same service PA can be used for different types of FAs. Maybe in terms of TV, I need a bigger UI, bigger layout, different types of features that are provided for TV. The same thing when I use on a smart watch, I need just a simple screen or multiple screen. But ultimately, the functionality that we support in both the cases is the same. Only how it is projected to the user, what kind of access it is given, that is the one that changes. So this is more on that one-time development for multi-device development deployment. We will see some use case in the coming days to showcase this feature. So next we will go for system security. The system security is one huge domain by itself in Harmony, how the entire process has been done, how the architecture is done. On the need basis, we will always add more information. Right now, the most important thing we should know is what is the subtitle that has been given. Right person, right device, and right data. So the entire meaning is only the right person through the right device gets the right data to access. So let's see a little bit more on that one. So this entire security system, what I said about permission management, that is related to one application. What we are seeing here is at the entire OS level, at the distribution level, distributed architecture level, what is this right device, right person, and right data? What is the meaning of it? There are different types to tell who is the right person, right? So always we have one authentication mechanism to tell whether you are the right person or not. There are different types of illegal access that access of data that can happen. As I said, from lower secure device, we can also get, if it is not properly managed, we can get secure information. So how do we handle it? One thing to know is always question whether the person who is using is the right person. We have multiple methods to do that one. The first one is zero trust model. So here we don't trust any entity. Always we try to authenticate. Suppose in the distributed network, you have two devices where you're trying to access. Let us take an example and explain more. I have two phones, mine and my friends. Two phones are there. We both are clicking pictures. I want to access the photos of my friend because we are in the distributed network and we have given access. But since I employ zero trust model, whenever I try to access the photo, there will be a pop-up on my friend's phone. This guy is accessing your pictures. Is he allowed to access? So this is zero trust model. Always you ask him to authenticate. There is a multi-factor authentication. This is a different model where we try to authenticate using multiple forms. This many of you would have already seen in your OTTs. If your smart device, if your smart TV, if you log in, there might be a two-factor authentication that comes into picture on your phone to enter the PIN that is shared on your phone. Right? So this the same thing can be done in many ways. You have a smartwatch. You try to enter the code in a smartwatch so that it is. I think somebody's mic is open. Can you please mute it? Vinay? Yeah. Okay, so that is our multi-factor authentication. Collaborative authentication is more like we try to engage multiple factors to authenticate at the same time. So here we can take an example where authentication is derived by other devices authentication. There is one device where it provides a OTP where through the other device we authenticate whether that device is valid or not. So this is collaborative where two or three devices together make sure it is okay in that distributed environment. Next, we will go for right device to know whether the devices we are accessing are secure. So maybe I am authenticated in every place, but the device itself is hacked. So here we have different types again. There is a secured boot system that is there in all the devices, where this will make sure each of our devices are not rooted. I think you would have seen in many forums are there where it allows an Android OS or iOS to be rooted. So you can still root, but when you use that rooted device into this distributed system, it says it's a non-secure device to be part of the distributed system. So the secure boot makes sure and it will inform us whether the device you are accessing is secure or not. T is trusted execution environment. There is a separate hardware and a microkernel that is there in all of our devices probably now to store our secured information. For example, your keyguard lock or your lock screen, whatever you share the information, right? Whether it can be a pin, pattern, face, unlock, all this information is digitally converted and encrypted, and it is stored in TE. Nobody can hack this system unless they know the right keys. This is only given at the production level. Whoever is a manufacturer at the production level, apart from that device, nobody knows how to access your system, your TE environment. The last one is for the IoT devices that we were saying, that is the device certification authentication. Whenever in the Harmony ecosystem, IoT device is made, a device certification process is done, where each of the device is said whether it is HarmonyOS compatible or not. So it goes through some basic validation based on 1 plus 8 plus N, our soft bus, and our distributed system network. Certification process is executed, and once that is the device goes through this certification and it is certified, in its production level, each of the device will have a private key that is burned at the production level. So whenever this devices that gets communicated with our Harmony ecosystem is validated from the server, telling whether it's a valid system or not, valid device that is part of my distributed system or not, or even in a one-on-one communication, it validates whether it is proper or not. Or else what will happen? Similar kind of device certification can be always mimicked if it can be done. So we always use UDID, IMEI, or different types of unique identifiers to identify the device in the system. So there is a dedicated server that tells whether it is a valid device or not. So that's how each of the devices are validated and the data is preserved. And write data. So write data also corresponds to data generation, distribution, access, and data deletion. So when I talk about data generation, so in the distributed network, data generation can happen from any of these devices, starting from a very small hardware. It can give sensor information to a very high level of contact information. Data is generated in different levels, but only a higher secure device with higher permission can access the right content based on the user. The data across Harmony also is accessed through single identity. So each of this device should have a login through one or the other means. It should get connected. Definitely, IoT devices might not have logins, but the little higher devices like tablets, you can say smart screens, your TV, these will have logins, and all these logins should be from a same account. So the moment this account is same, it helps to create the distributed network among all the devices, and the data across all these devices are accessed like a resource pool. So data storage is another part. I can click a picture in my phone and I can save it in my other phone or a tablet or a TV. But the same thing, if I generate contact information or a secured information, I will share where it has the highest protection, maybe the TE information. So for each type of data that is generated, the data tags are also attached based on which the security algorithms come into picture to showcase or highlight what can be stored where. And in terms of data transmission, this is already explained how we go through from one layer to another layer. And the destruction of data during a distributed network, when it is defined, certain set of caches or a temporary data is generated. So that gets destructed the moment the distributed environment is stopped. So this is all about the security that we have here. So with that, I think we have covered majority of the things. So next will be more, today I wanted to cover another topic, but that topic, if I start, that itself needs another 1 hour of time. So that is our application process, more to do in terms of this layer, the application layer. In the video, we saw something about FA, AA, all these things, right? So tomorrow session, we will discuss more dedicatedly only on FAs, PAs, and how it is packed in HAP, how the now multiple modules, applications are, application apps are packed into a single application, how it is maintained and how it is distributed. So we will first understand this, and then we will also start with the introduction of Deveco, what are the things we will do, and the starting of our development process on HarmonyOS. So I hope that will be a good point for all of us to do. I think you guys can ask any questions.
I just wanted to know what is the full form of HAP, application HAP, that you
HarmonyOS application.
Okay.
I just wanted to ask one more thing. Hello?
Yes, I'm here.
Can you go a bit to this soft bus slide?
Yeah.
Where this actually fit, like we have talked about our main architecture, right?
Yeah, I will show that also. So you can see here, intelligent soft bus. This is that part.
Okay. So we are saying like there are some devices, a number of devices, right?
Yes.
Where that will go, like?
You mean to say?
Where that layer will go, like here, intelligent software is something related to bus center, tasks, and bus something else, right?
No, these two are different. This is different. This is more to do for this stack, or intelligent software bus stack is majorly used for communication between two hardware entities. So it can be any two entity. So what we are trying to say here is, so you are talking about, hold on. Where does this go, right? So
Yes,
this is,
yes,
you are
yes.
asking about. Okay.
Yes, that protocol stack and everything.
Okay. So when we talk about on a major level, right? So at the system level, we have all that information. You can see here telephony, right?
Yes.
So telephony is one, location is one. Here you will have connectivity modules like Bluetooth, Wi-Fi. These are all framework and system services of that particular devices. But in service layer, we will have multiple modules which is linked for those devices. So here the driver is there, right? It can adapt to any type of device or peripheral devices that are there. Through driver and through kernel's driver, it is linked to the system service. So the main bridge point for the hardware is this one, driver subsystem.
Okay.
So here you can say you will have a connectivity chip. Connectivity chip usually consists of Wi-Fi, BT, location, IR, radio, RF radio. So those things will be part of it. Along with that, in terms of if you talk about our modem, that is our radio network. That by itself is another process that it will be running. So usually we will have two types of process in mobile device. One is for rest of the stack, one dedicatedly done for radio network. So there is a modem which has its own firmware on which it will be running. It receives all the signals, and then it will through IPCs, it will do this one. It will communicate with this architecture.
Okay.
So rest of the hardware is connected with this. Only modem has few of this. Even some of the firmwares like even for Wi-Fi, Bluetooth, there will be firmware that will be part of modem. Anybody else have any doubts? I see many names, but usually I get queries from one or two.
Sharath, Vijay here. I have one question.
Yes. This one.
What is the corresponding or component for DVM, Dalvik Virtual Machine?
We have here runtime, right? We have Arc multi-language runtime.
Okay.
So this is equivalent to that. So it contains, does a runtime for JavaScript as well as Java-based virtual machines.
Okay. Thank you.
I think if no more queries, I will stop the share and let's see if Wilfred, you're online. Okay. How you guys have, I hope all of you have done the setup of Deveco by now.
Yes.
You can run the basic, your HVDs are working and you can run any application. Sample templates will be already available. I think you can use those and try to run few samples. Anyway, we will discuss more on it from tomorrow.